All right, welcome back to the December meeting of the Hampton Ship Model Society. This is the presentation portion. Gene Berger is going to tell us about photo etching.
Part two. Okay, should we go slideshow? Is it ready to go?
I think you're still in it.
New slide.
I don't think we are in slideshow. Here we go. All right. Now, I don't know what you did, but it doesn't work again.
I was trying to avoid all the.
Yeah, it seems to work there, but not.
You have to restart.
All right. As I was saying, okay, let's pick up where we left off. Photo etching is the process, or as I previously said, photochemical machining is technically the process that we're going to discuss today. And it basically is a matter of producing a mask which is applied to a substrate, whether it's metal, in our case, could be glass, stainless steel, anything that is etchable that can be ruined with chemicals. And then using that mask to protect the materials from acids or whatever your etching material is to produce your parts or image or what have you. The photoresist is the medium that creates the mask. And it comes in negative forms, positive forms, and that depends on how you want to produce your image. In my case, I'm using a negative photoresist so that the areas that are black will prevent the light from sensitizing the material, hardening it, if you will. That will then be affixed to your brass. And it's usually sensitized by UV light. And as I said, the photoresist is hardened by the UV, and dependent on whether you use a negative or a positive film will determine how you present your image. You want the parts to be white when you design it. That will permit the light to go through. If it's black, then it would not. So you have to match your design process with the film that you're going to be applying to your device, your metals. And this is a image basically of the whole process. You've got the materials. You clean the materials so that the photoresist will adhere to it. You apply the photoresist to both sides of the material. You print from a negative which you produced. It then sensitizes portions of the photoresist, and then when you wash it in developer, it washes away those areas which were not sensitized and thusly hardened. And then you have produced your mask, which is attached to your material. And then from then, it's just a matter of etching away everything that is not protected. And the masking doesn't have to be. I mean, you could conceivably draw with a, let's say, a permanent marker. That would prevent the etchant from affecting the brass. It could be tape. It could be anything that prevents the acid from attacking the brass. That's all you're producing at this point with the photoresist. The products that I use, I started out with a micromark kit. And if anyone is interested in getting into photo etching, this is a good kit to kind of cut your teeth on. It comes with everything to get you started. Here you have your chemicals, your bath excess, clips, tongs, laminator, tubs, the substrates, the film, the carrier sheets. I recommend kind of going this route. Not that I like Micromark, because honestly, I think that their products are a little overpriced.
Very overpriced.
But it taught me the procedure. and quickly then taught me the limitations of what the kit can produce and how it works. So this is where I started going out into on the internet and started perusing sites that cater to the home circuit board makers. They use the same process, and so tanks, kits, and things that they use evolved and migrated to. The Micromark produce or sends you a pre-mixed sodium hydroxide solution, which is used in their process for both development and stripping of the mask after you're finished. I moved from using that as a developer because I found that it was more caustic and acted more quickly than the product that I moved to. That is a little slower to develop, giving you a lot more leeway and time to get it right. Because even the diluted sodium hydroxide used as a developer will strip off all of the masking if left in long enough. So the timing is more critical with that because it does act more quickly. I moved to, and you can purchase this stuff online from Amazon in hydrous form and mix it yourself. And it's infinitely more cheaper than what you get pre-mixed from Micromark. So this is the way I do. I use the sodium hydroxide solution for stripping the mask after the process is done, and then the sodium carbonate for the developer. They both work a little bit slower, gives you a little more leeway, a little more control of the process. The etchant solutions that I prefer are the sodium and ammonium persulfates. The kit that the Micromark sells and the go-to etchant is the ferric chloride. It's a little more efficient. It works on a wider variety of products, steels and things like that. But the downside of the ferric chloride is that it's opaque. It's a dark color. It can stain clothes. It's just a little messier to work with. Whereas the sodium and ammonium persulfate are clear, they etch sufficiently well, a little slower, but then again, it gives you a little more control. And the chief advantage is that it's clear and that in the etchant tank, you can watch your process occur in real time. So when it's done, you can pull it out and you're done. Whereas with the ferric chloride, you have to keep fishing it out to check the progress on whether it's done or not. It's not critical, but it's more convenient. And a note on chemicals such as these. The sodium and ammonium persulfate, actually all of these chemicals can be neutralized using either bicarbonate or sodium hydroxide and so forth like that to render it more safe. But none of these chemicals can go down the drain. They all need to be disposed of properly not because of the chemicals themselves. Once they're safe, if they've not been used for etching, probably could be disposed of in that manner. But once you've etched, it draws the copper sulfates and ides and all that crap out of the metal and goes into solution. And that's what is the problem. You get that introduced into the water system, and it's difficult for the water treatment plants to deal with and so forth. I don't know at the small level that I'm dealing with that's an issue, but it's really the law, and you should dispose of it.
Well, how many uses can you get out of that one? Say you make a batch.
A bottle like these produces a gallon of solution. The etchant tank may take a half of that, and each fill of the etchant tank, it depends on how much you etch. I mean, if you etch a lot of metal, it's going to saturate the solution more quickly, and then it becomes less and less effective over time. And you'll see in further slides it'll turn from a clear to kind of a bluish color. That's the copper that's being infused, that's being drawn into solution. And eventually it'll start to I don't know what the chemical term is, solidify, crystallize. And at that point, the solution is probably pretty much used up. And it's a matter of just disposing of it and just refilling the tank. I use to keep the mixtures as clean as possible. I just use distilled water, just gallons of distilled water. Keep the jugs or the reused or the used solutions back into the jugs. Store them at your toxic dump site in your basement until you're ready to dispose of them with the local authorities, or they'll come to you. I don't know, whichever occurs first.
Newport News has a hazardous waste drop-off thing.
Exactly. Each municipality rules may vary slightly, and they have their own facilities that you can take them to.
The once you make your solution, these are crystals in the jar.
Yes.
Yeah. And once you make that, does it have to be used, or you can? Does it have a
No,
shelf
no,
life?
no. I store them in glass
Yeah.
glass jugs, and then just use it as
Yeah.
I need. The Micromark kit also contains laminator carrier sheets. I still buy this material from Micromark because I have not found a suitable alternative otherwise. It's a paper, kind of like a clay paper, maybe like a photograph paper. It's kind of semi shiny on one side, and but these can be reused over and over and over again. I tried using like a clear, I mean not clear, but a shiny photographic, high quality photographic paper, but that did not work because the I guess the mask would stick to because it's too shiny or too smooth. There must be, I'm not sure exactly what paper, and I can't get the information from them. They won't tell me for some reason. So I still have to get this occasionally from them, and that's what the carrier sheet looks like. And this sheet is used to transport the processed brass with the mask through the laminator to protect it from the heat and to smooth it out.
You can reuse that.
Yeah, you can reuse them, and I'll talk about that as we get along. This is the product that I use for the masking. I mean, for the masking agent, this is the film, and then this is the transparency sheets, which you will print your negatives onto. This both come from Amazon, and this comes in a box of 50 sheets. This will last you a lifetime. Well, in my case, a couple of weeks. And this film I found, oddly enough, through the folks that do a lot of screen printing. Same process. So this film I've learned to use. And once you found a film that works for you, it's kind of a balance between the film, the processing time, the illumination time. They all kind of play in together like any photographic. If you're familiar with the basic photographic process, it's basically the same thing. The more you expose, the more you have to develop. But there's a critical point where the balance is, offset. You have to make sure it's exposed enough and developed at the, correspondingly. I'll get into that. Comes in a black sheet like this, and once you open it, you need to work in a kind of a darkened environment. I use a bug light. That works fine. Anything that doesn't produce UV radiation, you want the light. A very darkened room would work. These little pads are used for burnishing and cleaning the brass. Again, you can get them from Micromark. I have not found a better or suitable replacement for them yet. And it's used to polish, like I said, clean the brass before you attach the substrate. These are just some of the products that I use. You'll need a cutter, something to weigh your chemicals with so that your solutions are accurate, and a magnifying lens helps in aligning your negatives. The brass products I just get from Amazon. It's cheaper than buying them from just about any other source, and they come in packs. different sizes. And some other little things you might want to use, little filters and things, scissors. This is the laminator that comes with the kit. But I've since then stolen a regular, laminator from my wife. And you get those at Office Max, just the standard laminator. I needed a larger one because I was etching larger sheets. These are the products, the tanks that I got from Circuit Specialists. They deal with a lot of folks that do the home circuit boards. And they have the whole line of stuff. So if you're interested in going that way, you can certainly contact them and order. As you can see, the etching tank that I use, it's not overly expensive. They sell a variety of light sources. This is the one that I ended up with. What can I say? It's a hobby. But this is really nice because it has a vacuum system on it. It has bulbs, and reduced what I previously was exposing at 13 minutes with a regular bulb down to 55 seconds. So you do a lot of etching. It's worth the investment.
You talked about with the etchants that you liked having the more leeway because it etched slower. Now you've gone the opposite direction with the exposure. You don't have a
Well,
problem.
13 minutes is a lot of time watching
Yeah.
the grass grow,
Yeah.
But the difference in time between the ferric and the ammonium, I'm talking just a couple minutes maybe. It's not that big a difference in etching time. The chief advantage was the clarity of the solution. This is the tank that I use. It comes complete with a thermometer, and it can hold 8 by 11 sheet of brass. It has a pump for agitating and a heater element. And this is what I've gone to. And as you can see previously noted, I use this tank over here with the ferric chloride, and you can see how it's starting to stain up. And if I had continued using it, it would just become worse and worse and worse. This side is relatively clean, and it always stays this way. And these tanks last quite a while. They are plastic, and they will eventually break or wear out. But for $60, you get yourself a new system that lasts for a long, long time. Work close to a water source. You're going to need it for rinsing, for other purposes, for cleaning your brass and so forth. You don't have to have a sink. You can have a tub of water next to you. That would work just as fine. As I said, heating element for warming up the solution. Both of these chemicals can be used at room temperature. We heat it up a little bit, maybe to 42 degrees or something, 40 degrees. It helps the chemical process speed along a little bit by warming it up. You don't want to get, especially with the persulfates, you don't want to get it too hot because there's a critical point where if you go above that, you'll ruin the solution. I'm not sure exactly chemically what's happening, but it'll crystallize solution, and then it becomes inefficient. There's my go-to printer laminator. The agitator, just a regular old fishbowl bubbler. And now these are the couple of tanks and baths and things that come with the Micromark kit. You can use any size tank. Obviously, the bigger the brass, the bigger the tub you're going to have to use. I've gone to glass bottles and so forth to store my chemicals in instead of these little tubbers. The strainer is used for after you finish the entire process and you strip your mask. There'll be little bits and flecks of mask left in the solution. You can reuse it. So I'll just pour it back into the bottle through a strainer to save the stripper for another use. And I haven't replenished that for forever. Just keep using it until it stops working. This was a handy purchase I got from one of the auctions. In fact, it used to be Bill Clark's little backlight. This is a great alternative to hanging the negatives on a window to align the two. Remember I said that you're going to apply mask to both sides of the brass. Well, you're going to have two negatives which need to be indexed together so that the brass will slide in between it. So you're etching from both sides. You want to make sure that these two sides match up. So I use a light box for that. And that's the whole station right there, from front to back. Got my chemicals up on the top here, and there they are, the glass bottles, spares, mixing bowls, and so forth. And that's what you need: the stripper, the developer, and the etchant, and a neat little box to store your sensitized brass in once you've produced it. Before you expose it, you want to keep it away from light. So that's basically the mechanical part of it. Oh, the rest of it is just playing with chemicals. So you can we'll start the process and see what we can go from there. Well, the first thing you want to do is dress appropriately
Morning hair.
for the occasion. You are dealing with chemicals, and if you're a klutz and start splashing this stuff around, you may want to use eye protection. The gloves, nobody can work in gloves like that. But I haven't used gloves, but if you want to protect your delicate manicure, just use some rubber surgical gloves or something thin that you can handle with. But I've not really seen the need for it. The apron, definitely overkill. I don't know where I got that from, but it seemed to fit. All right, the process. Now that we've talked about what you need to get going, process is as we go. You just have to start with a plan. In this case, this came off of a model that I built of a sub chaser. These were the depth charge racks, and I wanted to make them out of brass. Well, you got to start with a plan, and these were the plans that I found. A little bit overkill, but they tell you exactly what you needed to do. Now, it does help to know something about how origami works. You've got a three-dimensional object you want to create out of a flat two-plane, just a flat two-dimensional surface. So you got to imagine how you're going to draw this thing. So you got to disassemble it in your mind somehow to lay it out flat so that you'll be able to then reassemble it. And this is how we basically ended up. I drew this on the computer. I use Photoshop. You don't need any fancy CAD work. All you about do is just draw lines, fill, and circles, things like that. And Photoshop, in my case, seemed to fit the bill. And this was what I imagined the part would look like, all laid out. And it's you can see some of the parting lines. These lines were used so that I could fold the part easily, and everything you see in black will eventually be washed away. Everything in white hopefully will stay, and that's where the mask will be on your brass, where the areas in white are.
So how do you keep the bend lines from fully washing away? Do you just keep an eye on it?
I'm sorry, what was that again?
I said, how do you keep the connection between the parts that you want to fold? Like you have those lines in there, I guess, to make it easier to fold, but you'd still want them to be connected to the main part.
Correct. In this case, imagine that this white area is a piece of brass, and I've got sprues connecting the parts to the rest of the area. You see how they go straight out and connect.
I think his question is,
Where
you're
got the
doing
black
front
foam
and
line.
back. There's a line on one side, but it's solid on the
Oh,
other.
is that what your question was,
Yeah.
Joshua?
Yeah, it's like, how do you not wash it completely away when you still want it to be connected?
Look on the right-hand side.
Okay. Well, Okay, there's two things going on here. The sprues that you can see here, well, you can't see it on your, here.
We can see it.
Okay, right there. You see where I'm pointing with the arrow?
Yes.
Okay, that's connected to the outer area. Imagine the whole white area is a piece of brass. Those sprues connecting will keep the parts attached to the main brass part and not wash away. If you did not have those, yes, your parts would separate and just go floating in solution, and you're going to have to go fishing for them. Now, the other question that Greg had was
I
that,
think it was actually Joshua's question.
okay, well, there is a difference. This is the front part, this is the back. The images are mirrored and flipped. And where you see the line here will etch only halfway through. The way the etching process works from both sides, it etches from both directions at once. And where it meets in the middle will be a hole.
Got it.
If there is a line there and there's no line there, this line here, and there's no line here, the line there will only etch halfway through, producing a parting line that you can then use to fold the part.
So I guess in that way you can achieve texture too that way.
Exactly. And it's all in how you design the part.
Got it.
And,
Thanks.
and you just, here you can see the sprue lines in in a little more detail. They show up a little better, and that keeps the parts from fishing away. Yes.
You said you use Photoshop.
Yeah.
Are you using the rulers to the sides to scale it?
Oh, absolutely. Yeah. There's a scale across the top of Photoshop, and I usually work in millimeters. It's just easier than trying to translate 7/8. You know. So yeah, and you can enlarge this image to as big as you want to get the details in there, and you'll know exactly how many millimeters. Through experience, you'll learn how much you can get away with, how thin a line you can make, and not to go beyond that. Because again, because of the way the etching process works, it works down and will undercut the mask. And if your lines are too thin, you can conceivably undercut that line away. The longer you leave the brass in the etchant, the more undercut you will get, because once you've cut a hole in it, there's nothing more for it to eat. It's just going to start eating sideways. And there's just a close-up. Don't worry about the jaggies around the edge of the part, because the etching process plus the printing will make that smooth. Besides, that's a gross enlargement. I mean, this part is probably only about maybe 3/4 of an inch. That will disappear.
Gene,
Yes.
question.
Yeah.
I never actually did etching, but I did artwork for photo etching, oh God, many years ago.
Yeah.
And I gave it to an etching company in Buffalo. And the product he gave me back, all the photo etched parts were sitting on a substrate with no sprue. So what you did is you peeled the part off the substrate.
Yes. Yeah. I have also done that.
Oh, you have done that.
Yeah. If the parts are too small and the sprue is going to end up being bigger than the part, well, how are you going to separate it? What I did was I basically took electrical tape, a large, a wide piece of electrical tape, and applied that to one side of the brass. The other side had the photoresist, and I just etched it all the way through
From one side.
and then the parts were stuck to the electrical mask or to the electrical tape.
Very, very, very interesting. Okay, thank you.
So essentially, that's the same process that they use. They use some sort of a sticky substrate to attach the brass to, and that works very well.
Thank you.
Gene,
Yeah.
this is Joe up in Rochester.
Sure.
The undercutting, is that because the uh, photo is light is not directly perpendicular to the plate when you expose it? Why is that?
No, that's because the chemical doesn't care where it's going to go to eat. It's just going to eat whatever's there. So it's going to start initially down straight, and then as soon as it gets beyond the thickness of the mask, or almost immediately, it's going to start etching sideways too. The thicker the piece of brass you have, the more undercutting you'll have, and you'll see if you look at under magnification that there'll be a little bit of a kind of a little a line on the edge of the brass, and that's where the acid has, or the etchant has been eating sideways.
Got it. Thank you.
Yeah. Yeah, the mask will only protect the very surface, the very, the very surface of the brass. Anything beyond that, the acid's going to go down and sideways too. It's not going to, and the thicker the brass, the wider the wider the minimum line is going to have to be too. You can't obviously have a line that you want to protect thicker than the thickness of the brass. Does that make sense?
Yeah, the undercut.
Yeah, because the undercutting will end
Just
up
cut away
eating it
the
away
line.
before it's finished. Yeah.
You won't have a line left.
So if you have a 5/1000 piece of brass, you can't make a line 5/1000 thick because you'll end up with net zero. You got to have a thicker line than the thickness of the brass. Okay.
It's 5,000 very much.
No.
Yeah.
So again, we have a negative here, and we'll just remember that with the negative photoresist, the areas in white are going to be your parts. The areas in black are going to get eaten away. Okay, front and back, as I mentioned before. Again, the details on one side, on the back side, no details because it's going to be glued down and you're not going to see it. So you can conceivably etch details on both sides, but you can't cross the lines. Otherwise, you're going to end up with a line or with a hole. So don't cross the streams there. Or you will go fishing for them at the bottom of the tank. I have done it. And with Photoshop, you can cut and paste as many parts as you want, which is nice, and then just develop your negative.
Crossing the lines bit. I mean, if you only go quarter of the way through on each side, you'll be able to do that, right? If you're just doing like relief etching.
Yeah, but as long as there's a sliver of something to hold it together, you won't have a hole, but you will have a hole on either side of it. Anywhere two lines cross.
If you let it etch all the way through, but if you're just doing like
Oh yeah, you can partially etch on both sides. Yeah, absolutely. But then how are you going to know when you're going to cross that line until there's
trial
a
and
hole there? Okay, let's go to actually doing some work here. The inkjet printer negative sheet I found has two surfaces. One side is slightly etched. The other side is shiny. You want to print on the slightly etched side. And there's an easy way to determine, just take a ballpoint pen in the corner and just draw on it. If it wipes off, wrong side, flip it over. And that's what you'd use to print. Just feed it into your printer and then just print it out. I use just a regular inkjet printer on high contrast, no grayscale. Photo etching process is black or white. And there's your negatives. At this point, it's just a matter of cutting them out and assembling your negative. You've got two parts, the front part, the back part. You want to sandwich the negatives printed side to printed side. And then to index them, in this case, I used a window. Before I had my light box, you tape one side of it up to the window, then you lay the other one on top of it, tape it together, making sure that it's indexed properly. You can use a magnifying glass. Oops. And just, line it all up. You don't need any fancy index marks in the corners like you see printers do and all that stuff. And no, just make sure all the parts line up, and it's easy to see with the light coming from the back side. Use a light box. That's more convenient. Saves from all the griping you get from having to clean the windows.
Now, when you do that, you lining up the parts, on your negatives, the printed side the ink side, does it need to be towards the brass, or can you have it on the outside?
No. You want to put the printed side together, because when you slide the brass in between it, you're going to have the printed side against the brass on both sides.
Yeah, the reason I ask that is, you're gonna expose that to UV light to get your negative, right? To expose
Okay,
the brass.
I think what you're asking is, technically, you could do it the opposite side. You went shiny to shiny, but then you're transmitting the light through the medium, and you're not going to get as sharp an image against your brass because of the thickness of the plastic.
Or you're
medium.
saying the shiny part of the plastic will reflect the light back, you won't get the
Not
exposure.
necessarily. No, that's not the point.
It's like the parallax error when you're using a measuring cup. The line's printed on one side of the glass, and you're looking through it. You have to, what I'm talking about.
The light bends.
So if the printed side is outside, the light's going to go beyond that printed bit sideways, and it'll cast a shadow. So to speak.
I got you.
Yeah, so it won't be as crisp an edge. So you want the ink against the brass.
Okay.
All right. Okay, now the next step, you've got your negative, put it aside. Now we want to produce sensitize the brass. And cut yourself a piece of brass to size. Again, I just use a chop cutter. That works fine. Anything over about 10 thousandths, this works great. You're going to work with 15 thousandths or 20 thousandths brass or more. Then it gets problematic. It'll dull the blade pretty quick. And when you cut your brass, cut yourself a piece of carrier sheet larger than the brass so that you can feed that through the laminator. You want two of them, one for each side. Okay, here we go back to the source of water, because you're going to need a little bit of water at this point. Scrub the brass. I use those polishing pads from Micromark. They're 3200 grit. And what you're doing is just you're removing any oxides, any oils and things that are always present on brass. Try and keep your fingers away from it, because once you've polished it up, you don't want to start putting your fingers back on it, get the oils on it. It could affect the adhesion of the mask to the brass.
Have you tried bartender helper?
Pardon?
Use bartender helper to clean brass?
No, you don't need anything. This is more than sufficient. I've used some old brass that had some stains on it, and it almost looked like corrosion and stuff. This will polish it all off. You just want to get it smooth and polished, and it also imparts a very minute texture to the brass too, which aids the masking to adhere to the brass.
I guess would wearing gloves at this point help?
Just hold it from the very edge, And now you want to cut yourself a piece of film to match the brass. Cut a couple of pieces, and you want to do this kind of in a dark room atmosphere. I use a bug light. For this particular film, works great. Different films may have more sensitivity or less sensitivity to light.
What kind of light?
A bug light.
Okay.
Yeah, just a yellow light. You could go full blown photo.
And how to blood light.
Photo room light. I used to have a red light, but the red light affected my ability to see the thermometer and colors and things like that. Bug light works just fine. And it comes in a roll. Just cut off what you need. Put the rest back in the darkened tube that came in. Put it away, and then put the film. I usually, if I'm not going to work immediately to put the film on the brass, I'll put it in another box somewhere aside while I go do something else. You don't want to expose it to light at this point. Now, the film itself is a 3-layer. Sandwiched between 2 thin cellophane layers is the actual emulsion. In order to attach the masking to the brass, you need to remove one side of the protective coating that's on it, and you just put a couple of pieces of tape, one on each, on the corner, and then just kind of pull them aside, and you'll see that the protective cellophane will come loose, exposing the actual emulsion. You want to lay that down on the brass with water, and then the water adhesion will suck it to the brass. Then take a squeegee. I use like a rubber roller that maybe the printers might use to work from the center to squeegee out all the excess water and kind of, press it to the brass. It can still come off very easily, so handle it judiciously because you're going to flip it over and do the other side too. And then once you've got the brass and the 2 pieces of film semi-attached to it, or at least mechanically attached to it, you want to put it on a piece of between your carrier sheets. And then at this point, you're going to run it through your laminator, and the heat will fuse the film and the brass at this point. Now remember that the film still has the outer protective layer on it. You just leave that intact for now while you're going through this process, and also the next when you expose it. Leave that extra protective layer on it so you can handle it now from both sides. Take it out, flip it over, run it through again. Ensures that your adhesion is good. Now, occasionally you may run into a slight problem. Maybe there's a bubble appears, or some other distraction. You can take an X-Acto blade, pop the bubble, run it through the laminator again. 9 times out of 10, it'll just fuse it back down. And if you have some other anomalies in your film, they're not necessarily bad, because depending on how you put your negative in, you might be able to avoid that area by putting it in an area that's going to be etched away anyway. All right, so we flipped it over, we cooked it again, we put it in the safe box to move on to the next. Yeah, that was good stuff. At this point, it's light sensitive. It's like a piece of undeveloped film. So you need to keep it dark. And essentially, this whole process is like the photographic process. You got a negative, you got film, you expose it, you develop it. So very akin to it. Okay. Here we slide the brass between the 2 negatives. And it's done. Now here's the fancy box. Put it in. You want to make sure that the negative is hard pressed against the brass. This is where the vacuum system comes in. It works great. Previous to this, I used to have to take the whole negative sandwich in brass between a couple of glass plates, put some clamps around it, and that was annoying. So it's a hobby.
At this point, is that outer protective layer still on the phone?
Yes. Yeah. You don't need to fool with that right now. So you develop it. You expose it. In this case, it took 55 seconds. And after you pull out the exposed brass, you'll notice a slight ghosting. That's where the emulsion has hardened. Where it's hardened, it's darkened. It changes color slightly. Where it's light, has not been exposed. That was the dark areas of the negative. And that is the area which in the next process, the development will be washed away. And you can see this on the brass. All right, move on to the developer. Now you remove the outer layer of protective cellophane. If you don't do that, the process is going to stop. I know. I've done that many times. I'm sitting there going, What in the hell's going on here? Been in here a half hour, hasn't done anything. Well, I forgot to take off the film. It can't get to the emulsion. Got to remove the film. And at this point, you just drop it in a tank I use yeah. Oh, I forgot. I'll call it developer. It's sodium. What was it? Sodium carbonate. Yeah, solution. And like I said, I like using it more than hydrogen. I mean, sodium hydroxide because it doesn't work quite as rapidly, and it's a balancing act. The more you expose, the more you're going to have to develop to a certain point. If you overexpose it, you may never be able to develop it because the areas that are supposed to be washed away are too developed to wash away, and it will just extend your development time. So you have to kind of learn the balancing between exposure and there's a key point where it seems to work out best. At this particular point, with these chemicals, with this light source, with this film, 55 seconds works out great. And with a little bit of agitation, just keep washing it, and eventually the emulsion will wash away, and you can see it happening. I mean, it'll just kind of cloud up, and you just wash it away. It'll cloud up a little bit more, and you just keep doing that until the brass is shiny. There's no more emulsion, and at that point, it's completely developed. You don't want to leave it in any longer than you have to, because any longer, it's going to start affecting the rest of the mask. Rinse it off, and you're basically ready to put it in the tank. At this point, you can inspect it, make sure that there isn't any more emulsion left. And if you find some anomalies, drop it back in the developer. Wash it some more until you're assured that all the emulsion is washed away from the areas you want to be etched. And then the actual process is just a simple matter of dropping it in the tank. I just use some brass wire or just any kind of wire, protected wire. You don't want to put any unexposed wire in there, otherwise you're going to eat that away. And you're going to go fishing for it, your parts. And there you go. Now it's in the process. You just let it sit, and when it's done, it's done. You can watch it. Over a period of anywhere from, depending on the thickness of the brass, 5 to 15 to 20 minutes. If you use maybe 20 thousandths brass, something really thick, it may take a half hour, but eventually it'll get there. Go out and mow the lawn. As I said, the gals will tell you when it's done. When it's done, it's done. And there's this little more of a close-up of it. And as it progresses, the solution will absorb the coppers and metals and eventually kind of turn a bluish color like this. It's still perfectly usable. I usually reuse it until it starts to whatever the term is, precipitate, crystallize. At that point, then the chemicals, it'll start clogging up the holes. The aeration doesn't work. Now it's time to clean the tank out and put some fresh stuff in there. And here you can see the process of nearly done. You can see through where the etchant has eaten all the metal away, leaving your parts. And I appropriately left all the screws on there, so all the parts are still attached to the tree, so I don't have to go fishing. So that was a good day. And you can make as much as you want. These are now put in the sodium hydroxide once they're done, and this will then loosen all the mask from the brass at this point. And as soon as the emulsion comes off the brass, it's done. Pull the brass out, rinse it off. You don't want to leave that stuff in the sodium hydroxide for a long time, because it'll eventually just dissolve all the plastics and stuff and ruin the solution. Just pull it out and throw it in the trash. And, brass is brass. I mean, there's lots of parts. These were, I think these were components for the United States model I built.
is that time sensitive from the time you pull it out the tank to putting it in the rinse?
No. You mean talking about removing the mask? That's what I
When
mean.
you take the parts that you've had hanging in the etching solution, you take them out, say, you might have 10 minutes, you're putting another.
Oh, no.
Is
Once
it
the
time
parts.
sensitive to put in the.
Yeah, no. Once, yeah.
What would you say? It would,
It's
it's like putting baking soda in acid.
Yeah, no. Once the parts are etched and you pull the brass out of the etchant and it still has the mask on it, just rinse it off to stop the etchant process. There might be some sort of ammonium persulfate or something on it. Just rinse that part off. And then you can just, it's done. It's just a matter of, you have to remove the mask at some point to reveal all your parts, your brass. But that's not time sensitive. It's not photosensitive. It's nothing. It's just the sodium hydroxide will remove the mask, what's never left that's covering your parts. And that's not time sensitive either. When it's done, it's done. Yeah, go ahead.
Gene, I have a question. If you etch something, I can understand that you etch through, but if you want to half the depth or bending, how do you control it? What goes through and only half?
Okay. Previously on the negative, it depends on how you design your artwork. On one side, let's say you want to produce a line
Yes,
that you're going to use to fold.
yeah,
Okay, on the front side, you draw the line. When you duplicate that image and flip it over,
no line.
no line. And that's the negative on the back side. So when you sandwich the negatives together, you'll see a line on one half and no line on the other negative.
Therefore,
And that's going to prevent it from etching.
I understand you cannot have, when you etch from one side, that one side goes deeper than the other.
No.
You have.
No, they both go the same distance
Understood.
to the halfway point.
Makes
And when they
sense.
both meet in the middle, you got a hole.
Unless you leave
And
it
if
too
and if
long.
there is no etching from one side and it goes halfway through, it's not going to go any further.
I have a question.
Oh, God.
I'll try to keep it short. They do a lot of, like the copper plating on these modern wooden ships,
Right.
copper plating. Well, very often you see that the nails or the fasteners, and it's at the very outline, okay? Now in reality, there was something like 100 nails on one of these plates. Now, 80% or maybe even 100% of the stuff you buy are much too big. I mean, you see them, originally they were flat nails when they were nailed down. They really didn't stick out from the copper at all. Now, what I've been thinking, theoretically, you could make a two-sided, two forms. One side you show the nails, on the other you don't. But then you etch it only for a short time, so these are barely shown.
Right.
Take it out and you cut the outside by hand, you would have a very low
Is there-
indication.
What I'm thinking.
I'm
he's
not
talking-
finished there.
Okay.
I mean, what I'm getting at is you could theoretically just etch the nails in very lightly, take it out, which is obviously won't cut through,
Right.
and then cut the plates by hand.
You could do that. Or if you wanted the plates to be separated, just etch the nails halfway through one side. And if you use a thin enough piece of brass, those are going to be so shallow. And if they're too big, just take a little bit of abrasion, sandpaper or something, and just give it a 1 or 2, and then that'll flatten them down a little bit.
Because all these nails usually are way too.
Yeah. Well, that was the deal I was trying to sell Sean on originally when he.
Or you could just use a stamp.
Oh, yeah.
Yeah, but I've seen lots of stamps. I've seen where
Yeah.
you stamp them through, then they roll them on the other
Yeah.
side. It doesn't look good.
I just wondered if you took your picture that you're And instead of it being black, you could gray that area so the light will partially go through it?
No, that doesn't work. That doesn't work in this process.
Oh,
It's either on or off. Yeah. There is no grayscale in photo etching. All right, you got your part. Now you got to figure out how to put it back together. And this is what the part ended up being. You can see at the top, just in rough brass. Obviously, there's some other components and the details I added. But otherwise, I don't know how else you could have done something like this. I mean, this whole thing is probably, what, about 2 inches, maybe 2.5 inches large. So this process lent well to this need. And here's some other.
Can you go back a second?
Okay, what are you questioning?
Did you have a separate piece here which you folded over and glued it on? You know, the reinforcements on that.
Oh yeah, no, those were added on. Those were just some structural pieces. Yeah, this is what I started out with, the basic basket. And the rest of the materials, the details and things, I could always add to it. And just some an example of some of the other smaller parts and things used to assemble some of the other depth charge racks. So it's like I said at the onset, it's a matter of looking at a part and disassembling it part by part so that you can reassemble it once you've made your individual
Part
detail
on the
parts.
bottom right that's almost in line with a 20 millimeter mark that have a line etched through it for bending.
This, yes.
Yeah, the pointer's not working on this.
Oh, okay. No, I was pointing it for the people.
Yeah.
You're talking about that right there. Yeah. So that I could fold that part, and that part ended up being, I forget. It's in there somewhere. And if you need pulleys, you got lots and lots of pulleys. These are pulley ends that I did for the SS United States. So I mean, it's left up to your imagination. I mean, if you can draw it, you can make it.
Gene?
Yes.
Silver solder to put the assembly together?
No, I just use regular solder. I mean, sometimes, yeah, no, I haven't really done a lot of silver solder. It's a bit of overkill, I think, for stuff like that I've done. I've just used regular electrical solder and stuff like that to assemble most of my brass. I have, though, used different temperature solders. Maybe inadvertently, I use some silver solder. If there's a critical component, like a larger structure that you have to add a lot of smaller pieces to, it's beneficial to use maybe a higher temperature solder for the major components, and that would reduce your risk of desoldering components as you add and layer to it.
And folding, hand folding?
Soldering the folds, you mean?
Hand folding, I think.
Well,
is-
when you fold the part like that,
Well,
oblong,
I just use one of those little folding aids that you can buy in any hobby shop, that you can clamp your part into and fold it.
Yeah, come on,
Oftentimes, I'll just use a
something like that.
pair of flat pliers or hemostats or something that I've used. With something like 5,000 brass, I mean, it'll fold just by looking at it. So, all right. So what can you make? I mean, there's no limit to it. These are some components from, let's say, the Olympia that I'm building now. You can see up here the ladders. These are some ladders all in brass, some gears for the steering gear. Here is it assembled down at the bottom, the accommodation ladders. I couldn't find wooden, what do you call it, those slats, gratings and stuff. So I just make it out of brass. And you can do the artwork so that here, if you look at the very bottom here, it looks kind of like a multi-layer fair. It's just in all how you design your artwork. And then these were all just soldered together and supplemented with a little bit of wood and so forth, they turned out fairly well. And then again, this is on the Olympia. Here you can see up at the top left is the gear train for the steering on the actual ship photo I took in Philadelphia. And then right below it, there's an image of the gear parts that I had etched and produced. Again, over for the ship's wheels, it had some brass trim in it. How was I going to do that? There's no way I was going to paint that. So I produced some brass and then repainted the inside between the brass to give you the effect of brass trim. So there's almost, I mean, anything you want to do, you just have to imagine it. Here is a vegetable locker. That's what the original looked like, made up of components soldered together, painted, and they look fairly convincing. The turret on the Olympia had a lot of rivet detail. I don't know how else I could have done it other than to etch it, because you could draw it out in ultra straight lines with all the little details and partings and things you want to put in there. So I etched it. There's a badge on the bow of the ship. The name on the back were three-dimensional, and in order to do that and paint it, I used a hybrid method of combining decals over a brass etched part rather than try and paint it, and it worked out extremely well. And it's the same process to produce the decal. Once I drew it out, I used the same artwork then to produce the negative or the brass, so that they're completely indexed in the same dimensions and size. I wanted to produce this bronze plaque that was on the ship, and I used exactly the same process, the hybrid decal etching process. Basically what I did was I took a photo of the image, squared it up in Photoshop, isolated the layer that I wanted to produce. With etching, you can only produce 2 layers at a time. If you want to go deeper layer, I could have produced a 3rd layer and then soldered it or glued it on top of it. But in this case, the relief was sufficient with 1 layer. So I removed the back layer, removed all color, posterized it so that it's completely black and white, and then produced at the bottom, the back. And this ended up being my negative that I produced my brass etched part. And then I added the decal, which was made from the same image, and applied it over the brass. So you have a deep relief image, actual image of the bronze plaque. So it looks pretty convincing. And I don't know how you could have carved it or made it any other way. This whole thing is probably about 1 inch tall. And one more item, same process. These are the sideboards, the wooden sideboards. Started with an actual image of the sideboards, produced negatives, images for the negatives from the image. And then once I etched the brass, I applied the decal over the brass. And there you go. It looks like a wood carved piece, miniature. So you can use the process to do lots of effects, and this is where we are today, and that's basically the end of the project. I hesitate to ask if there are any questions. Oh, good God.
How much does that micro mark you suggest to buy?
It was like 130 or 40
Yeah, I
inch.
think you showed about 36 or something.
Yeah, it may be 130-ish to 40. I don't know what their current price is. Yeah. I mean, it's a good starter kit. But as I said, if you start getting more involved in the process and want to learn and do more with it, you'll find that it's very limited in what it can do. Primarily, the biggest piece of brass you can put in there is maybe about 3 or 4 inch piece of brass, just the way, because they have a small tank that they design, and it doesn't. I don't know. It's just not as efficient.
Good way to, it's good basic training.
But it teaches you the process, and you learn the concepts, and then you do like I do. You move on to better products, more more efficient products.
Where do you get your decals?
Oh, the decal sheets. I just
Amazon.
yeah, Amazon sells them. Any hobby shop sells them, and you can buy them with a white background, a clear background, laser, inkjet versions. And yeah, just those were just printed out on a white background decal film using my inkjet printer.
$120. This price, 180. Our price is
Ah,
I think it's a little more expensive when you add the shipping.
I committed simultaneously to memory every word that you said. But if I forget something in the future, would you suggest a good source for the progress of that instruction?
Can I post this on our website?
oh sure,
Slideshow?
sure. Yeah, it's also on my website, but put it on your site. Yeah, why don't you take it with you, and I'll just leave it up there. So, because this is an updated version, because I added a lot of the products that I currently use. I don't think I have that on my site.
Okay.
Gene, it'd be awesome is if there was a shopping list.
Shopping list. Well,
Yeah.
well, when the program's over and Greg posts it online, just go through the show. I think I've listed all the products that I use, and most of the things I get are from Amazon. I used to source from other places, but I've kind of concentrate on Amazon now because it's convenient. They have it, and
I'll search on Amazon for the things he mentioned and add links to whatever it is that I post. I was going to do that for my own sake anyway.
yeah.
What you can do actually is, and I've seen this in other places, is you can create a shopping list within Amazon and then share the list.
Yeah. Well, I hesitated to give Amazon, business, I guess, if you will. But I mean, you can source it from wherever you go. I just happen to fall on Amazon because of convenience. But you may be able to find it cheaper other places. Certainly, Circuit Specialist, where I got my tank and the exposure box from, also sells chemicals. And I originally sourced from them, but they took so long sometimes to ship. And so I just found an alternate source. But there's always other places to go. And these are some of the products that I happen to use. But there probably are alternatives. This is just what I use. And it works for me.
We'll list it just as an example.
Yeah,
As they
yeah.
have to.
Yeah.
I use Amazon all the time, so I get it.
Yeah, yeah. All righty. Well, if there are no more questions, I'm hungry.
All right.
Oh, we still haven't finished the meeting.
Oh, yeah.
Oh.
Let's show and tell you.
Oh, damn.
Well done, Chief. Well done.
Yeah. Good.